So, we all know that computer programs run on the computer. Most programs rely on an operating system, but what if there wasn't one? Can you make a computer run your code with nothing pre-installed? Yes, but you have to build everything yourself. On bare metal, there is nothing. No libraries, no memory allocation, no scheduler, no debugger. If something breaks, your kernel just reboots endlessly with no error messages. That said, it is still pretty rewarding. Seeing the thing you've been debugging for last week finally up and running hits harder than any YouTube tutorial would. The drawback? The bug you've been debugging turns out to be a pretty easy fix. All you had to do is change from passing the struct to passing integer instead. Now, I'm talking from personal experience. Or another one, something I will remember for long is off by one. Now, I'm not gonna dive in on what happened, but all I want to say is, when you want to read with BIOS interrupts, don't try to overcomplicate stuff and calculating sector offsets. If your code is in sector 9, just set the CL to 9. You don't need to do anything else really. But what's the purpose of that video? Well, I just wanted to show you how far I've come, and that if I can, then obviously you can too. So what the project is? The project is called Laskar, named after a volcano, which I thought would be cool and because it can explode any minute. In a nutshell, it's an OS built from scratch with a file system and basic shell. Now, let's take a closer look. So, any OS consists of many components combined together. The first one that you always need is the bootloader. It's a program that is going to run right after computer boots up. Its task usually just set everything up and launch the kernel. So, the BIOS reads only one sector from the disk, and one sector is a standard of 512 bytes, not much, right? That's why bootloaders are usually split into stages, usually two. In my case though, I decided to take a different turn. Why? Because I barely touched any assembly ever and writing driver on it felt like an infeasible task. So I made a 3-stage bootloader. Stage 1 is slim to fit within the 512 bytes. All it does is loads the stage 2. Stage 2 sets up paging, stacks and everything else needed to activate 64-bit mode and launches the CFAT32 parser. Parser then looks through the file system to find the kernel.bin and launches it. And yeah, we didn't do much yet, but you already need an ATAPIO driver and a file system controller to at least read. The next step is kernel. What can you have inside the kernel? Well, mine doesn't have much yet, but for at least some demo you probably want to output something and process user's input. And yet again, even for this basic functionality you need drivers for keyboard and screen. But once you do, well, congrats, you have somewhat usable learning project. Now it's up to you how you want to interact with the user or what commands you want to add. Mine has some standard Unix commands for file system interaction such as echo, ls, cd, mkdir, cat, with load keys since query is default but I'm used to dvorak, and a snake command, the funniest one. The story behind it is pretty interesting. You see, I wanted my OS to be something bigger than text. I wanted to make some game. I wanted graphics. The problem? I couldn't make it work. No matter what I did or how I approached it, it refused to work. So I decided screw it. I didn't even need the graphics anyway, and made a game based on VGA text mode. Now, it's pretty basic, I know, but it works. My next big goal is porting everything to UE5, because legacy BIOS, while educational, is complicated and unstable. UE5 throws you straight into 64-bit mode with a frame buffer already set up. No mode switching, no manually enabling VBE. Plus it's modern, most OSs use it. Other than that, I still want to learn quite a bit about heap, data structure, schedulers, user space and so on. So my plan is to do all of that myself eventually. It's gonna take a while, but I believe it has a ton of value behind it and is absolutely worth it. And if you've ever had this crazy idea you wanted to build but never did, go do it. Just set realistic expectations. If I set out to build a Linux competitor, I'd probably never start either. Anyway, thanks for watching and have a good day.